I am now. Welcome back from spring break, boys and girls. I'll be your new math teacher, Mr. Smith. Hi. But even though my name is Mr. Smith, I'm going to go by Dude McNasty. This is 6th hour. So, how many of you remember the positive and negative integers sea of zeros stuff? Okay, and at least you remember carrying around those green and red, or like green and pink integers. Okay, we're going to discuss that a little bit, and then we're going to go back, and I'm going to show you how to do it algebraically. So, we're going to learn how to do two-step equations. You guys have actually had a little bit of two-step equations during the CSI Collins Swag. Okay. CSI Collins Swag. We've done a little bit of this, but we're going to represent that. Now, I want you to write this how I write this, even though some of you don't have the ability to draw a cup, just do a box then, but we're going to do circles. So we are going to represent this example using integer squares or integer coins. So we have 4 positive integers. So 1, 2, 3, 4. 4 positive integers. Then we have 2 of an unknown. So we have 2 cups with X number of integers in it. And that equals 8 integers. So I'm going to do 8 more integers over here. 1, 2, 3, 4, 5, 6, 7, 8. And they're positive. Yes. Yes, we have done this before, but it was the second week of school, so you guys were just little baby 6th graders acting like 7th graders. No. Have you seen any pictures of yourselves from the beginning of the school year? 7th grade is a funny year. Okay. Now that equal sign means that it's equal on both sides. It has to be. That's exactly what it is. 1 equals 1, because both sides of the equation is 1. So to represent that, I'm going to show that these guys are already taken care of. Okay, those are the same exact integers. So I'm going to circle those. Now we have 4 integers left. We have 4 integers left. And that's going to be put into 2 cups evenly. Right? So how many of these integers should be going into each cup by looking at this picture? JT. There's going to be 2 in each one. And actually, so that means that X equals 2. There's going to be 2 of those going in each one. And I'm going to, rather than draw a circle, this is what I did last period, but you guys can, so I drew a circle going to this guy. Okay? Drew a circle going to this guy and drew a circle going to that one. But I'm going to visually represent it a little bit differently since I had the tech to do it. So those 2 go into that bucket. Those 2 go into that bucket, and each of the buckets there's 2 positive integers, and that almost looks like a character. Okay. Make sure you leave some room up here, because we're going to get back to that. All right, we're going to come back to that. Now this one's a little bit more challenging, because we have some negative integers here. So we have 5 positive integers. 1, 2, 3, 4. I'm going to put them in order. 1, 2, 3, 4, 5. Positive, 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 positive. And we have 2 X's. So we have 2 cups with who knows how many integers. And we have 7 negative integers. And I'm also going to use this opportunity to remind you guys that the word negative, when it's with an integer, we could also say opposite. Okay? Negative means opposite. So rather than normal 7, it's opposite 7, which is negative. So we have 1, 2. I'm going to put it down further. 1, 2, 3, 4, 5, 6, 7. Now I need to do a little sea of zeros to represent what is going to be that positive integer 5. So in order to do that, I have to create a sea of zeros. So I'm going to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to create a sea of zeros to represent that. Oops. Sorry. There. Now, if this doesn't make sense to you, just hold out and we'll see if it makes sense algebraically. If it doesn't make sense to you like this, nor algebraically, then I can see you during activity or when I give you guys time to work. So next I'm going to do is I'm going to take care of these positive integers there. So I took care of those positive integers. Now, up here what we did was we had circled those and we had to distribute whatever we had left into those cans. What is left now that we need to distribute into those cups? Yes? Negative how many? How many integers are there? 7. We have 1, 2, 3, 4. Ooh, I don't want to do that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Yeah, because there's now 12 negative integers there. So how many negative integers need to fit into those two? Well, there's 12 negative integers that need to fit in those two cups or cans or bins or whatever it is. How many is going to go in each bin, Briley? Do you know? We have 12 of these, and they're going to go in evenly into these two cans. How many is going to go in each one? So there's 3. We still got some more to take care of, though. There's 4 in each one. 6 in each one, yes. There's going to be 6 in each of these. So since that is 6 goes into x, this 6 is x. So the answer is x equals what? Is it a positive or negative 6, though? Negative 6. X equals negative 6. Now, when we're solving the order of operations, when we're solving two-step equations, we need to use the order of operations, but a little bit different. Because when we solve for equations, are we going the regular order of operations order? So aren't we undoing stuff to a variable? So if we're undoing stuff to a variable, it has to go backwards. We do the order of operations backwards. And that backwards is going to be sad map. It's a sad map. And I drew pictures for the other class, but I'm not going to draw a picture. You can just imagine a sketch. Yeah, oh, I have shown you guys that one. Okay, good. It's a map that's sad. Because you guys have actually done some two-step equations before. Twice. Once on purpose, once without letting you know. So we're doing sad map. Excuse me. There are some special exceptions to this, and that's including when, I'll zoom in. An exception is when the whole side is a fraction. And in that case, multiply by denominator. It's just information that's written in your notes, so you should keep that in mind anyway. So when it's with a fraction, you multiply the denominator first. Or when it's a fraction, you multiply first. Okay? So we're just doing the order of operations backwards. And that doesn't mean you turning around and doing the same equation. That dad joke. Want to see me do the alphabet backwards? They turn around. A, B, C, D, E, N. Thanks. It's not original. Let's do this algebraically. We have to do a SAD map. SAD map. Because rather than please excuse my dear Aunt Sally, it's Sally, Aunt, dear my excuse please. Or, so, it's like, what are you guys doing in math today? Or it could be, what is it? No, what did I say earlier? Something like, so another dumb math equation, probably. So another dumb math equation, probably. So, yeah. The what? Why?
Because it's so long.
No, it isn't. So what we have order of operations, and this S from the order of operations is what? Yes. Subtraction. Do we see any subtraction here? No, we do not. Good. So we go to the next one. Addition. Do we see any addition? Yeah. So how do we undo the addition? And keep in mind here that you want to undo what's being done to X. X is very asocial. It doesn't like anyone. It only likes to be over here by itself, and that's when it's not a sad map. It's a happy dude, okay? Or dudette. Now, keep in mind that this here is a positive integer. So how are we going to undo that positive integer, Austin? Subtract 2? That wouldn't work because 2 is being held on by multiplication with the variable. Yes. Subtract 4. The first step we're going to do is subtract 4. So we have 2x equals 4. Now what's happening to x? Dara? It's being multiplied, so we have to divide. Exactly. So we're going to divide by 2, and we are going to get, boom, x equals 2. X is equal to 2 in that situation. And here's how it represents what we've done. We have a subtraction of 4. We got these guys to be no longer a problem or a factor of what we're doing. And then we divided by 2 right here. And look at this. We divided those numbers by 2. Okay? If it still doesn't make sense to you, let's try another. And if it does make sense to you, let's try another. Now we have a negative integer on the right side. Is this one of those special exceptions? No? What's the special exception again at the bottom of your page right now? Yeah. Okay, good. So the whole side's a fraction. Okay, so that's not that situation. Good. Whew. You do not like special exceptions. So we have 5, which is a positive integer. In order to undo that, I have to subtract 5 from both sides because addition. Oh, I need to have this up there. Sad map. The reason I keep writing it on there, and the reason why you guys are writing on there, is because I want it to be on my screen. But you guys, when you have your homework, when you do it just one time on the top, it'll be on your screen the whole time. Okay? As in you'll be able to see it and have that reminder. So I have a SAD map. I have subtraction or addition, so I'm going to take a subtraction. That leaves me 2x 2x and negative 7. So now I have multiplication. How do I undo multiplication? Yes? Yep, I'm trying to do too much. Thank you. Negative 12. Now, some of you really struggle. And by you, I mean 7th graders, not individually people in this class. Many 7th graders struggle with the idea of integers. Please, please, please draw this on your stuff when you are working. Okay, I have 7, negative 7, 0. Whenever I am subtracting, I'm going further that way on a number line. Whenever I'm adding, I'm going this way on a number line. So just writing that and thinking about that. When I subtract, I'm going to the left. When I add, I'm going to the right. So does it make sense that I got negative 12? Is negative 12 this way from negative 7 on the number line? Yes, it is, because it's subtraction, and it's going to be a higher absolute value, but it's going to be negative 12. Next step I need to do is I'm going to do divided by 2, because I have to undo it's being multiplied by 2, and boom, goes the dynamite, x equals negative 6. X equals negative 6, and that's the same way that we found it. And here are those two steps. We are getting rid of 5 on both sides, and then we are dividing our negative integers into two different things. And that's how those are represented. Yes, sir? No, if you guys were to do it like this, that would take you hours to do your homework tonight. I do not expect you to do that. This is to show you how it's done and how it's represented and what's happening when we're undoing the stuff to the variable. Yes, sir? Somebody want to tell them? I'll tell them. I just answered that question. The answer is no. You do not have to do the picture. I don't expect you. Yes. I've taught you 2 ways to do it. I said I don't expect you to do 1 way, so what does that leave? Yeah. And we're going to do actual examples right now, so that'll help. Okay? Now, to further answer your question, sir, we are writing out step 1 and step 2 of this. I don't expect you to do that. I expect you to just show me, okay? I expect you to just show me what to do there. So, step 1, I'm going to go ahead and write this. You guys just write it one time on the top, please. Sad man. Said meep. If it had 2 E's in there, it would be meeker. Muppets? Jim Henson? No? Okay. What needs to be the first step in this example 1? Is there a subtraction there? Mustak? You have to get rid of the 5 because our second step in here is addition, so we're going to look at that next. And the inverse of addition is subtraction. Excuse me. Step 1, we have to subtract 5 from both sides. Subtract 5, both sides. Sorry, YouTube headphone users. Yep. So I'm going to represent that. I'm going to write this out as well, and I'd like you to do the same. Goodness. So I have 85 equals 4D. I cannot write D's today. D, there we go, it's beautiful. Plus 5. And I did purple. So I subtract 5 from both sides. Subtract 5 from both sides. That leaves me with 80 equals 4D. What's my second step? Now I have 80 equals 4D. Yes, Collier. Great. Our inverse of multiplying by 4 is divide by 4 to both sides. Divide sides by 4. So that leaves us with just D on that side and 20 on this side. We have a happy variable because they're asocial and he's just chilling by himself and smiling. Okay. Wonderful. Example 2. Any questions on example 1? Yeah.
On the homework, will there be like a step 1 and a step 2?
No, you will not be expected to write step 1 and step 2, but I will expect this stuff to be there. It'll look like these. Okay. All right, example 2. Oh, I see a fraction. Special example. Multiplication first. Right? Special exception. I see a fraction. Special exception, right? Because I'm looking at my notes while I'm taking my homework. Yeah. Yes, you are correct. It's only the whole side when it's a fraction. This is 2 operations. We have addition and a fraction and division, yeah. So it's not the whole side. This is not the special exception like this one will be very shortly. Okay? That's the whole side as a fraction. This side is just there's a fraction in it. So I have sad MEP. You do not have to write it this time. I'm just keeping it so it's on my screen. Okay? You do not have to write it this time. Sad MEP. Okay? What's the first thing I'm going to do? Sit up. What's the first thing I'm going to do? Caden? Subtract, because this is an addition problem here. Yes. I'm going to subtract 7 from both sides. Subtract 7 from both sides. Now, on your homework, for example, it could show this. Actually, no, it's on your homework it is a positive integer. Just keep in mind that it's a positive integer. In order to make the positive integer go away, you have to make it a subtraction. So we have to subtract 7 from both. I'm going to go ahead and rewrite this. 19 equals 7 plus b over 7. So I'm going to subtract 7 from both sides. I'll make it black. So that would leave just 12 equals b over 7. 12 equals b over 7. What's my next step? Yes. Multiply by 7. Yes. Multiply both sides by 7. Multiply both by 7. B equals 7 times 10 plus 14. 84, yep. 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 B equals 84. So we have example 3. This one has this special exception. And what does it say on the other side of your page? Well, first, it does, but the number example 3, what is it? We have to multiply by the denominator first because that's what you wrote down on the side of your page. So we're going to multiply first. So we're going to multiply by -7 both sides. Okay, I'm going to rewrite it down here. So we have 16 equals negative 8 plus s. Because this is actually what it represents. If I were to rewrite it, it could look like that. That's why we do the multiplication first, because parentheses are done last. That's actually what it is. Yes, sir? S. That's okay. I did the same thing to myself, both fourth and fifth period, where I turned it into an S, which is why it's good to have good handwriting or legible. Yeah, it's good. It's important. So we need to go blue. We need to multiply both sides by negative 7. So now I have 7 times 6 plus 7 times 1. 7 times 6 plus 7 times 1. Or 10. 119. 112, actually. Opposite 112. Now we have x plus, or 5 plus, what? Speak. Negative 8 plus s. So my second step is going to be what? I'm at negative 12, or the opposite of 112. Division would be a situation where you would have a multiplication left. But we're here, yes. Subtract negative 8. Subtract negative 8. This is what she's thinking. Okay, subtract negative 8. Let's move this down. Because Vanessa knows you can do this. Have that also be represented like this. It's S minus negative 8. Okay, S minus negative 8. And I could just make that into S plus 8. And how do we get rid of 8 then? Subtract 8. What did I just do? Yeah, we have to add 8. I didn't do that right. So we're going to add 8 from these guys. Because this is a negative integer here, plus 8. We have a negative 8. How do we make negative 8 go away? You add 8. You add 8. 8 to both sides. Or you can do the additive inverse, which Vanessa did, where she subtracted a negative 8. And that leaves us with (104) equals S. As we pass this guy, write Smith. So as we're going through this, as we just went over, the first thing we're going to do, because this whole side is a special exception fraction, so I'm going to multiply both sides by 7. So after I multiply both sides by 7, I'm going to have 7 times 10 plus 7 plus 4, which is going to be 98, equals the opposite of D. The next step that I'm going to do is I'm going to look at this a little bit easier. And we've done this before. There's a couple ways you can do this. The first thing is if you switch every single sign right off the bat, is the same thing as multiplying this whole equation by -1. Okay? It's like multiplying the whole equation by -1. So that's one way that we could do that. Okay, because you're doing it to both sides, aren't you? And if you're doing something to one side and doing it to the other side, it still stays equal. Okay, it's the same way that the way that we all age, we're all getting older at the same age. 1 year every 365.23 days. Leap years. So in order to do that, what I could do is, that's not really going to be necessarily a step, but I can make it change that sign, change this to a positive D, change that to a positive, and then a negative. So we already have a positive there. Positive, positive, positive. Right? Question? Okay, D. But here's the thing about that. What happens when you have two negatives right next to each other? Okay, so we needed to do this step next. It's not even really a step. We have D minus -5. When you subtract a negative, what are you actually doing? Yeah. You're actually adding a positive. So I can just take this guy and make it there. Okay? 98 is going to be negative because I'm still going to go back and switch all my signs because of this guy. Because I'm going to eventually divide it by 1. But I could get to that in a minute. So you want to continue with it the way that it is? Then I'll explain how? Okay. So we have opposite of D plus 5. So I'm going to take what's happening to the variable, which is a negative multiplied by it, plus 5, and I'm going to subtract 5 both sides. Minus 5, minus 5. 93 equals the opposite of D. So D is still not by itself. It has a -1 connected to it, and it likes to be alone. And if you have a -1 connected to your friendship, get away from them. Okay? Yeah, sure. So we have 93 equals -D. Now think of it like this. You do not have to write this part, okay? Do you agree that -1 times D is -D? Okay? So in order to get that negative to magically poof to the other side, because magic doesn't happen in science and math, we have -1 divided by -1 over here. And then we divide this side by -1, and that's how the -93 becomes -90. Becomes -93, and the D becomes by itself. Yes, you could just go from here to poof. Okay? That's fine. That's how you get that one.